Let's talk about calculating your index of hydrogen deficiency or degrees of unsaturation for molecules containing atoms of group 7. That's your halogens. Example, bromine, chlorine, iodine, right? Now, when you have molecules that contain halogens, this is what you do. You add 1 to the number of hydrogens in the unknown for each halogen, right? So you add 1 to the number of hydrogens in the unknown for each hydrogen, for each halogen, I'm sorry. So for example, if your unknown has 2 halogen, then you add 2 to the number of hydrogens in your unknown. Let's look at an example. So let's say you're given C4H6Cl2, and you're asked to calculate the index of hydrogen deficiency or the degree of unsaturation. So you have 2 chlorine, which means when you calculate the number of hydrogens in your unknown, you are going to add 2 because you add 1 for each halogen, right? So you add 2 to the number of hydrogens in your unknown, okay? So in essence, all we're saying is once you have a halogen in your unknown, if it's one halogen, you add just 1 to the number of hydrogens in the unknown. So let's look at how we would do this. Index of hydrogen deficiency is equal to hydrogen in your reference minus the number of hydrogens in the molecule that's given, which is called your unknown, divided by 2, right? So remember the hydrogen from your reference comes from your alkane, molecular formula CnH2n plus 2, right? And what you need to do, you go to the unknown. My unknown has 4 carbons. So the alkane that is the reference is the alkane that has 4 carbons. 4 times 2 is 8 plus 2, 10. So the number of hydrogens in my reference is 10. Minus, now I need the number of hydrogens in my unknown. This is my unknown. Your unknown is the molecule that they give you to find the index of hydrogen deficiency. So my unknown has 6 hydrogens, but it has 2 chlorine, right? So 6 hydrogens, remember you add 1 for each you add 1 hydrogen for each halogen. So I have 2 halogens, right? So I'm gonna add 2 to the number of hydrogens here. So number of hydrogen here is 6. I have 2 halogens, so now I have 8. The 6 hydrogens plus the fact that I have 2 halogens, so it's 6 plus 2, that's how I get 8, which is equal to 10 minus 8, 2. So you have 1 degree of unsaturation, okay? Let's, I will explain in a second why we add for halogens. And the simple reason is because when you introduce a halogen into an existing, for example, hydrocarbon, it replaces the hydrogen. So in order for you to calculate and get the correct value, you have to account for the fact that the halogen replaces the um the hydrogen. So let's take a quick look and then I'll do another example. So this is why you have to add. And honestly, if you don't remember the reasoning, that's fine. What you need to remember is that for halogen, you add. Okay, for halogen, you add. So this is what happens. Um, this molecule, right? The molecular formula is C4H6Cl2. Okay, the corresponding hydrocarbon, and remember hydrocarbon only has carbon and hydrogens, is C4H8. What I mean by the corresponding hydrocarbon is a hydrocarbon with the same number of atoms as C4H6Cl2. only has carbon and hydrogen. So if you realize what is happening here, Mark, pay attention. There's only 1 degree of unsaturation, 1 degree of unsaturation, and that is correct in both molecules. So if you notice what is happening when we introduce chlorine into C4H8, the chlorine takes the place of the two green hydrogens. Here are the chlorines. So if you don't believe me, go ahead and calculate your index of hydrogen deficiency. If you use C4H6 and do not add 2, you will get an IHD of 2, which is not correct because this molecule only has 1 degree of unsaturation. So in order for you to take care of, so to speak, the fact that the halogens replace the hydrogen, you must add once you have the halogen present in the molecule. That's the explanation. Like I said, you don't have to remember that, but you must remember you add. That's the reason you add. Simple. When you introduce halogens, the halogen into the molecule, it replaces the hydrogens. Let's look at C8H9 Cl3, right? Again, you know that your index of hydrogen deficiency is equal to H reference minus the number of hydrogens in your unknown divided by 2. Reference, I have 8 carbons in the unknown, so I need the corresponding alkane with 8 carbons. 8 times 2 is 16 plus 2 is 18. Number of carbons in my reference is 18. I have 3 chlorine and 9 hydrogens. Remember, chlorine, you have to add. So I have 3 of them, so it's 3 plus 9 is equal to 12. Please pay attention that I am adding the halogens to the number of hydrogens in the unknown. Please don't ever do add it to the reference. The reference is the boss. It stays. Don't mess with that. Right? You add it here. So you get 12 and 6 divided by 2, that's 3. Let's work one last example. What if you're given C7H7 Cl? All right. Your reference here would be C7. 7 times 2 is 14, plus 2 is 16. And all I am doing, right, is using the general molecular formula for your alkane, which is CnH2n plus 2. So 7 times 2 is 14 plus 2 is 16. So the IHD here is equal to 16 minus, right? Number of hydrogens in my reference is 7. In my unknown is 7, and I only have 1 chlorine, right? So 7 plus 1 is 8, and you divide that by 2 is equal to 4. So just remember, halogen add, okay? Halogen you add, right? If it's just a hydrocarbon, notice if you watch my first video for the hydro, you don't do anything, okay? All right.